Hi everyone, so today I'm going to be talking about piecewise functions. And as the name mentions, piecewise means that we're actually looking at pieces of functions, okay? So this graph over here to the left is called a piecewise function because it's a function that's defined by two or more different types of equations or functions. So I want us to look at it, and we're going to look at it's composed of, it looks like 3 lines, 3 different linear functions, okay? Now, we got to notice that some of them have closed circles and some have open circles. So an open circle means that it doesn't actually reach that point. It's not including that point, whereas a closed circle does. So let's look at how we're going to read these functions, but in order to do that, let's look at the domain. Okay, let's look at the domain of each graph. Now, when we're talking about the domain of piecewise functions, we're going to talk about them in inequality notation. So we're going to put aside interval notation when we're talking about piecewise functions for now, okay? All right, so if I'm looking at this function to the left, I can see that it starts at -6 and it goes to, it looks like -3. So I would have that as x is greater than -6 but less than -3. Now notice I used a compound inequality for that, okay? Remember, when we're looking at domain, we're always looking at the x values, okay? All right, so then let's look at the range of that function. So that's my domain, and let's look at the range. So the range of that function is from 1 to 4, but not including 4. So we would write that as 1 is less than or equal to y less than or equal, or less than 4, okay? Okay, now I'd like you to find the domain of the second and the third, and so press pause, and then come back and let's see if you got it right. Okay, if you're back, you would have gotten a domain of from -3 for the second one, so -3 all the way to 4, but not including 4, and the range would just be 2. And hopefully you're noticing that's a horizontal line. All right, the domain of the third line I got from 4 to 8, not including 8, and my range from -2 to 6. Okay, so always reading them from left to right. All right, so now let's look at those as a piecewise function, okay? So you might notice a couple of things, okay, how they played a role. The domain actually is written kind of to the side of each of the functions. Now you can see it says f of x equals, so here's function 1, here's function 2, and here's function 3. So it's really important for you to know what part of the graph you would be looking at. You could write them separately, we just don't write them separately. But it is kind of important to recognize that what's always going to be next to a piecewise function is the domain or the x's that you're going to look at. So I can actually evaluate piecewise functions the same way we evaluate functions, but now I have to pay attention to where my x is in the domain because it's going to indicate which function I'm going to look at. So here's what I mean. F of -4. So I have to go to the domain where -4 lies. So -4 lies in this domain, so I'm going to apply -4 to this function. So -4 plus 7 gives me 3. All right. Let's look at 0. F at 0 applies here, so that means no matter what, F at 0 is going to be 2. 6 is going to be in this domain, so that means I'm going to apply 6 to this function, so -2 times 6 plus 14 is going to give me 2. All right, so hopefully you get an idea of how piecewise functions work. Now these are all linear piecewise functions. They don't have to be, okay? So let's look at, let me scroll down. Yeah, I got everything there. So let's look at how we might write the equation. First of all, if you're writing a piecewise function for this one, how many equations do you think we need? Okay, hopefully you're saying 2. It's 2 raised. Now it is important to notice that these have arrows at the end. So these are going on forever. So I'm going to actually draw them out off the graph, which is what I ask you guys to do. All right, so what's the domain of the first ray, the left ray? So that's going to be -infinity to 3, right? That's how we would normally write it. So in inequality notation, we would say x is less than 3, okay? So that's how we're going to write it. Now, you could write it with interval notation if you wanted to. We just normally don't on a piecewise function, okay? All right, so the range of that function, so this is my domain. My range in inequality notation would be y's greater than 1, right? Because we're starting at 1 and we're going up like that. All right, my second domain would be x is greater than or equal to 3. There's my domain again, and we'd probably write that as 3, hard bracket 3 to infinity in interval notation. And my range would be y's greater than or equal to 4. All right, so that's kind of important, right? Now, we'd actually want to then, we could also write the equations. So the easiest kind of way to do it from the graph would be, to write it, because we always need piecewise functions to be in the y equals form because it's going to always be f of x equals. So that means we're going to have to use slope-intercept form, right? So this one, the one on the left, is actually not so hard. I can calculate the slope. So I'm going down 1, 2, 3, and right 1, 2, 3. So I have a slope of 1, and I have my y-intercept of 0, 4. So that function's equation would be y equals x plus 4. But the other one, it isn't so easy. So while you could just use the slope to find your y-intercept, let's see. My slope looks to be, I'm going to pick this point and this point. So up 2 over 1, 2, 3. Okay, so my slope on the other one is up 2 over 3. Ooh, my slope was -1 on this one, I think. Yeah, negative x. Sorry about that. So I certainly could go down 2 over 1, 2, 3, and then I'd have a y-intercept of 0, 2. Or I could use point slope and then put it into y equals mx plus b. So if I did that, because I love point slope, y minus y1 equals m times x minus x1. If it was a tougher equation, let's see, I've got the point on here. What is that? 3, 4. So this is 4, this is 3. And I know that my slope is 2/3. So I could do that. And I could distribute. So let's see. Y minus 4 equals 2/3 x minus 2, and then add 4. And there I've got my equation, 2/3 x plus 2. So I'm going to let you guys decide how you get the equations. But then once you have your equations, to write them as a piecewise function, we put it all together. So I'm going to actually scroll down here. So I'm going to write f of x equals, I'm going to write my little ampersand. My first equation was -x plus 4. But I'm going to look at that for x is less than 3. And then my other equation was 2/3 x plus 2. And I'm going to look at that one for x is greater than or equal to 3. And there you've written a piecewise function. All right, hopefully that was helpful. Have a good day.